And this kind of can be applied to a lot of other concepts. So it doesn't have to be necessarily ethanol, but what we're looking at here is the biological process versus industrial process. So we're going to compare these two methods and the pros and cons of each one, and look at some sort of the bits that are specific to ethanol, but also quite general processes and general concepts behind the two ways of doing it. So this is ethanol to start off with. It's got two carbons, it's got an alcohol group, so 2 means F, no double bonds, and then the alcohol group, so ethanol. And this is the active ingredient in most alcohols. Okay, so this is the alcohol that our body tends to react to. Other alcohols make us go blind and are much more dangerous. Now, if we have a look at how this works, so this is the biological process. You need a yeast cell and a bit of sugar, and this is how brewing happens. So when you make beer or you make cider, this is how it happens. You've got the yeast and you've got the sugar. They are left alone for a while to ferment, which produces energy for the yeast. However, the byproducts of this are ethanol and carbon dioxide. And this ethanol is the alcohol that essentially gets people drunk. Now, the problem with doing it this way is it has to be done in batches. So you can't just sort of continuously produce ethanol. You have to put the yeast in, put the sugar in, put the whatever you're getting the sugar from. So it could be all sorts of things like barley, for example, with beer. And you have to leave it for a couple of weeks, and then after a couple of weeks you would take it out and you would have to start from scratch again. So it's quite a time-consuming process, and it requires quite a lot of space to actually do. And it's also quite slow. The upside, however, is this happens at room temperature, it happens at room pressure, so at 1 atmosphere of pressure, and it's quite easy to do. I mean, you can do this at home quite simply. And so you can actually produce quite big quantities of this, and quite cheap. However, it isn't as efficient as doing the industrial process. And this is how we do that. So we get ethene. Now we can get this from a range of sources such as cracking, and you get steam. So that gives me the C2H4 plus the H2O, which will give me the formula of ethanol. I have to use a very high temperature, a very high pressure, so 60 to 70 times the atmospheric pressure that we have, and you have to have a catalyst, which again can be quite expensive. So these conditions here are significantly more expensive than the conditions here, where you basically put it into the vat and just leave it for a couple of weeks. This instead costs a lot more money to do. However, on the flip side of the previous one, this is very fast, so I can constantly produce ethanol, and any gases that aren't actually used, any ethene or steam that is not converted into ethanol, just gets recycled. So you are constantly doing this cycle until ethanol is produced and it comes out. So this is what we call a continuous method. You can constantly produce ethanol, and once you get the process going, it just keeps going, keeps producing ethanol. When you have a look at things like vinegar, for example, you'll know that you get sort of malt vinegar, wine vinegar, cider vinegar. That's where the ethanol from this process has been oxidized. So that's because this is used in a biological process. If you go into B&Q, you can get things like white spirit, which would be ethanol, but you can get these sorts of chemicals as well, which would be like a vinegar ethanoic acid, but it's generally much more concentrated, and it's not something you can put on your chips. It's got a higher concentration, and it comes from this industrial process. It comes from oxidizing ethanol that's produced through this process.